classes, CASAS testing, or any help with technology, there is a phone number you should call. I'll put it in the chat and I'll also say it, but it's 202-289. Sorry, just trying to find my chat real quick. Okay, no worries, Sashel, if your audio isn't working. So it's 202-289-6623, extension 128. That's the number to call if you're having any problems with any of those things, and just leave your name, a message, your number to reach you back and why you're calling, and somebody will get back to you within 24 hours. If there are issues, of course, you can also ask me or any of your teachers whenever you're having issues as well. But if there's something else you need to discuss with them, make sure you call. If you need a tutor, please provide your name and subject to me as your teacher or any teacher, and they will put you down on the list. And as soon as a tutor becomes available, they will get that to you. I've already submitted if you've asked before. Remember to check your email, your AOH emails regularly, right? All of our communication is going to come through AOH. So make sure you are checking those AOH emails, not your personal email. And then we had some winners for the town hall last week to get $25 Visa gift cards. And so the only person that's in this class is Tashelle. So congratulations to Tashelle. Your $25 Visa gift card will be mailed out to you. And there were also 2 winners for the trivia contest from last week. Neither of them are in this class, but we do have winners for that as well. So congratulations goes out to everybody, including Marvin Tucker, Jerry Campbell, Shamari Edwards, Amber Gross Gray, John Saunders, and Stacy Burrell. All right, but every week there's going to be some sort of trivia question posted in the homeroom class. And if you answer those questions, you can be entered to win a $25 Visa gift card. That's once a week. All right. Okay, great. So those are all the announcements. Again, hopefully these are done. Yes, perfect. All right, everybody has their pre-assessment in. Phenomenal, good work. All right, so let's look at this quick question here. So obviously we're going to be reviewing fractions this week. So we gotta get that fraction work in. So as I already saw how you guys are doing with fractions, what you guys remember about fractions, what you don't remember, we're going to go over it all. We're going to do, this is just part 1. So that means next week we'll do part 2. But we're going to have 2 parts where we are really just reviewing our fractions and getting our fraction knowledge where it needs to be. Okay. So we're going to obviously be doing addition and subtraction today, and I have a nice simple addition and subtraction question here in the warm-up. So it says, I walk 7/10 kilometers to work. I've already walked 4/10 of a kilometer. So how much further do I have left to go? Right? When I have the question that says how much further, that is obviously going to be a subtraction question when it says how much further, right? So as long as we're reading those questions correctly, how much further means I need to do subtraction. So 7/10 minus 4/10 is going to give us what? 7/10 minus 4/10?
3/10.
3/10. Obviously, right? So 3/10 is our answer for that one, right? Remember, we cannot add and subtract fractions that don't have the same denominator. If they do not have the same denominator, you cannot add or subtract them. You have to give them the same denominator first, or you can do something else, which is a little trick that we're going to learn a little bit later. All right. Okay. That's done. We have our warm-up done. We're going to go into Schoology, back into Schoology. 1 second here. Gotta switch my page up. All right. All right, so we are back in Schoology. And so if you all are watching the recording because you were not able to get into class on time with us live, remember that what you need to do today is the pre-assessment and also this vocab warm-up that we're about to go through right now, as well as the notes for today. We're going to do all of that today. So these first three things, the pre-assessment, the warm-up, and the notes, needs to be in today if you're watching this on the recording. If you're here live, you're already getting attendance for right now. Make sure you do submit one of the other things later on today for the rest of the attendance. All right, so that's what we're working on this week. We're doing fractions, so you have those first three things. There is a handout here about how to divide numbers properly, just a reminder of your divisibility rules, what makes a number be able to be divided by another number. That's going to help when we're reducing our fractions. Okay, and then you guys have 3 practices and an exit ticket all due later on this week, right? The first practice is on simplifying fractions, the second is on converting fractions, and the last is on adding and subtracting fractions. We're obviously going to go over all of those things before you have to do those practices, but just so you know, that's what the work looks like for this week. If you're just starting this week, only focus on this week. Do not go back and try to do the other work. If you find time that you have sometime later in this week or on the weekend and you're like, I have anything else going on, you can go back then and finish that work, but always try to focus in this week if you're starting this week. It's important that you stick with this week for the most part, all right? Next week, we'll build on this week as well, so that's why it's super important to stay in this week. So hopefully everybody will be here this week to do this work, and so they won't be starting brand new next week. Okay. So this warm-up, go ahead and click on this warm-up assessment and do that. It's just a quick little matching exercise to make sure we all have the right vocabulary. It's just a 1-question assessment on matching these words with their proper definition, right? So it should be a pretty straightforward little warm-up to do. We'll go over the answers very quickly, but what's a denominator? What's a whole number? What's a mixed number? What's a decimal? What's a percent? What's convert? Rational number, numerator, equivalent fraction. Go ahead and make that matching, do that matching really quick, and then we will go over those answers together, and then dive right into the notes. So the next thing you should have open are these notes. They're available in a doc file or a PDF. You want to open the PDF in Kami if you don't have a Word doc version. Okay. Do your warm-ups, do your warm-ups. Just 2 more minutes to do these warm-ups. They're pretty straightforward. You can do them, I promise. Y'all know these definitions. You've seen them before.
I don't see it. It's a fraction review note.
Right above that, it should say vocabulary warm-up. You see it? Right here, vocabulary warm-up, right above the fraction review notes.
Okay.
Yeah.
Okay.
We're gonna get started in just another minute or so. Everybody else is in. Perfect, perfect, good. All right, good work. We're gonna take a look at the question together. All right. All right, so a denominator is obviously what? What's a denominator?
It's the bottom number of a fraction.
Perfect. A denominator is the bottom number of a fraction. A whole number is one of your counting numbers, a number that has no parts. A mixed number is a combination of a whole number and a fraction. A decimal uses a dot to separate the part from the whole. A percent means out of 100. Convert, right, means to change to an equivalent form. A rational number is any number that can be written as a fraction, right? That includes your decimals and your percents. They can all be written as fractions. Numerator is the top part of a fraction. Equivalent means having the same value. And a fraction is essentially just a number in division form, right? All right, so that's your vocabulary warm-up, just to make sure we're all on the same page when it comes to this vocab and what we're talking about when we're talking about fractions. So let's go into these notes. These notes are a really great summary of all the things that you guys need to know. If you did poorly on the pre-assessment, or if you didn't remember things on the pre-assessment, these notes are going to be invaluable to you. I do want to stress though that if you guys are planning on taking if you're here to take the GED exam and you want to take that soon, this is something that you really need to be trying to memorize, how to work with fractions, all right? So that means doing extra practice with fractions, working through fractions a lot, and spending a lot of time making sure that you understand and are reviewing fractions regularly so that it's not new, right? You can't forget how to work with these fractions because fractions are going to be a big part of this exam. Okay, so if you have your fraction notes open, this is what it's going to look like. The first part is just going to walk us through how to do conversions, how to change from a mixed number to an improper fraction, and then the other way around, how to change from an improper fraction into a mixed number, all right? So a mixed number, again, it contains a whole number and a fraction. And an improper fraction is just a fraction where the numerator, the top number, is bigger or larger than the denominator, right? So to change a mixed number to an improper fraction, this is one of the questions you guys had on your pre-assessment, and a few of you forgot how to do it, but it's actually really simple. When we change a mixed number to an improper fraction, the first step is to multiply the denominator to the whole number. The next step is to add to that answer, the numerator, and then just put that new number as the numerator over the original denominator, okay? So we have 8 times 3, which is 24. 24 plus 1 is 25. That's my new numerator. So now I have 25 over 8 when I started with 3 1/8. Okay, so that's how we convert a mixed number to an improper fraction. Okay. All right, and then in the second example, it's not filled out. There we go. It is 4 4/9, excuse me. Yep, 4 4/9. So it should be 9 times 4, which is 36. 36 plus 4 is 40, right? Which is going to give me 40 over 9. Right? Always keep your original denominator when you're changing from a mixed number to an improper fraction, right? Or the other way around, you always keep the original denominator. That stays as your denominator. All right, when we change an improper fraction to a mixed number, we have to divide, all right? It's a whole division process, right? So we're just dividing when we change an improper fraction to a mixed number. We are dividing the numerator, the top number, by the denominator, the bottom number. So all we do is divide, in this case, for example, number 1, 47 by 5. When 5 goes into 47, it's only going to go 9 times. That 9, right, this becomes our whole number. That 9 is our whole number, and then we get 2 as a remainder. That remainder is the numerator of our new fraction, and of course we keep the denominator, so we have 9 and 2/5. All right, so some of you were a little bit confused about where those numbers go. I noticed when you were doing your pre-assessment, but you just keep the denominator where you keep the denominator, it always stays, it carries over. The number that you get from the division is your whole number, and your remainder is your new numerator. All right, so if I have 9 over 2, I divide the 9 by the 2, I'm going to get 4 as my whole number, 1 as my remainder, and I keep the 2 as my denominator, so I have 4.5. All right, any questions about conversions? I see something in the chat. Okay, you're saying you can't get into what to show, the notes? So the notes, again, are just in PDF or Word. So it shouldn't be an issue to open it with Kami, if you can open it with Kami, the PDF, or download the notes document onto your computer if you have Word, so you can open it. You shouldn't need Google Docs or Google Drive at all because you've been opening things with Kami before, so if one doesn't work, try the other. Okay. All right. It was saying it was paused. What was paused? Do you want to, okay, here's what we can do. Let's stop my share. Tisha, how about you share your screen so we can see what's going on, because I'm not sure what you're explaining. One second, I have to give you permission first. Okay, yeah, you can, yeah, you have permission, you can share. Go ahead and share the screen. Oh, I'm just supposed to share a screen, yeah, I can do that. Okay. Okay, so go to your courses. Go to Math Skills 5 with the red picture. Okay, week 3. Okay, and then you open up your fraction notes. And how do you want to open it? Okay, with Kami. Okay, great. Okay, it's open. All right. So you can go ahead and stop the share. That's at the top of the screen, or I'll stop it. It's okay. All right, so you're in. All right, let's go back to these notes. All right, so there's no questions about converting. We're gonna go on to reducing. All right, so reducing a fraction, making a fraction as small as possible is also something that some students find a little bit difficult and challenging because they have to use what is called their divisibility rules. So again, maybe I should pull that up. That's on it's in your folder as well, in case you need any help with that. So just in case, if you need any help with how to divide or reminders of how to divide, any even number is divisible by 2, right? How do you know if it's divisible by 3? You have to add the digits up, right? If the digits together added up are divisible by 3, the number is divisible by 3. And then the rules go on for the numbers as you go up. We don't need to learn the divisibility rules for numbers larger than 8 because at that point you have to be thinking too much. So try to use some of these smaller numbers first. That's really where you should be. 5 isn't on here and 2 isn't on here because those are the ones that we should remember. 2, any number that's even is divisible by 2. And 5, any number that ends in 0 or 5 is divisible by 5. Those are those rules for 2 and 5. But the other rules are also in here. And that is in your folder under week 3. That is your divisibility rules handout. If you need that to help you try to figure out how to reduce your fractions. Okay, going back to our notes. All right, so in order to reduce a fraction, we have to find a number that will divide into both the numerator and the denominator evenly. So that means it has to be the same number, right? We always use the same number for the top and the bottom. So if I have 10 over 15, right, and I want to divide them evenly, I'm going to use 5 because, again, they end in 0 and 5, so I know that both numbers are divisible by 5. When I reduce 10, so 10 divided by 5, I'm going to get 2. When I reduce 15, I'm going to do 15 divided by 5, I'm going to get 3. 4 over 8, okay? I might not recognize that 4 is the highest number that they can use, but I know that they're both even numbers, so I might start with 2. If you start with 2, you're going to get 2 over 4. You just have to do it again. You have to always keep going until the fraction is as small as it can be. It can't be divided anymore. But if I divide by 4, I'm going to get 1/2. All right? Reducing fractions or simplifying fractions are the same thing. So I use the word reduce or simplify, I mean the same thing. Okay? So don't get confused if you see one word or the other. When I say reduce or if I say simplify, I mean the same thing. That means make the fraction as small as possible through division. Questions about reducing fractions? Okay. All right, here's the hard part. The adding and subtracting. All right, so when we add and subtract fractions, there's one very typical way that you are taught when you have to add fractions that don't have the same denominator. And that way is to find the lowest common denominator and change it to the lowest common denominator and then add or subtract, right? But that actually is a lot of steps. And I figured out some easier ways. So of course, I'm going to give you these notes that have the very traditional steps, but then we're going to talk about a way that I think is a little bit easier to do it, all right? So here are the steps as they say it, right? Find the common denominator, raise each fraction to the terms as needed, add or subtract, carry the denominator over, blah, 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 right? Okay, so we can walk through this. So if I have 1/2 plus 7/8, what's my common denominator? It can't be any lower than my highest fraction, so what is my common denominator?
It's 8.
It's 8, obviously, yes. The common denominator here is 8. That means I'm going to have to change, as you can see in the example, I'm going to have to change this 1/2 into a fraction of 4/8. How did I do that? How did I change 1/2 in the 4/8? What did I have to do to make this happen? How did I make this happen?
You had to divide 2. See how many times 8 goes into 2. Well, 2
Right.
goes into 8.
Right, so how many times, so I have to figure out how to get from 2 to 8. Well, to get from 2 to 8, I have to multiply 2 by 4. Whatever I do to the bottom, I have to do to the top. So 2 times 4 is 8, and 1 times 4 is 4. So now instead of 1/2, I'm going to use 4/8 as my new fraction. Now that they have the same denominator, 8, I can add the fractions together. When we add fractions, we do not change the denominator. The denominator always stays the same, so it's still 8. So that all we do is we add the numerators. So 4 plus 7 gives me 11. So I have 11/8. All right, 11/8 is going to be a completely okay answer, right? But if you don't see that and you're doing a multiple choice, it might mean that because this is an improper fraction with the numerator bigger than the denominator, it's possible that the answer has been converted to a mixed number. And again, how do we convert an improper fraction into a mixed number? What do we have to do to convert? How do we convert an improper fraction to a mixed number?
You divide the denominator into the numerator.
Right, so we do 8 into 11. How many times does 8 go into 11?
1 time.
1 time. 8 times 1 is just 8. 11 minus 8 gives me 3. So 3 becomes my numerator, and I keep 8 as my denominator. So now I have 1 and 3/8. This is what they have here. All right. So that's one way to do that. So when we have two denominators that are different, we cannot add it together until the denominators are the same. We can list our multiples of 2. So we have 2, 4, 6, 8. So we know that 8 works for 2. So we'll just change this one fraction into a fraction of 8 is what we did here, right? Okay, here's another version that I find a little bit easier. So instead of changing our fractions at all, we're going to use a cross multiply method. Okay, so in this method, I have to cross multiply. So I do 2 times 7. What's 2 times 7?
14.
14. Good. What's 8 times 1?
8.
8, right? Good. All right, so those are my new numerators that I'm going to be working with, 8 and 14. All right, to get my denominator, I need to multiply the two denominators together. What's 8 times 2?
16.
16, right? Good. So now I have 8 over 16 plus 14 over 16. They have the same denominator, right? So now I can add them together. What's 8 plus 14?
22.
22. So I have 22 over 16. All right. So this is too big. I need to reduce it. And I'm going to reduce it because they're even numbers. I'm just going to use 2. 2 goes into 22, I get 11. And 2 goes into 16, I get 8. So I ended up with my same answer, okay? So you have a choice here on what is the easiest way for you to add fractions that have different denominators. You can find the lowest common denominator, change the fraction, and then add or subtract. Or you can cross multiply the denominators together, and then if you need to, after you add or subtract, then you can reduce the fraction at the end. All right? So those are your choices.
Can I ask a question? If
Yep.
I was to reduce it before you did it at the bottom fraction, would I still get the same answer?
So like if you reduce it here at this step,
Yes.
absolutely. That will still be the same answer. So if we reduced it here, let's say we reduced it by 2, right? But remember that the only tricky part here is that you have to keep your same denominators before you can add them together. So this fraction can be reduced further than this fraction, and then you're going to end up with 2 different denominators. That's the only danger there. So I would add first and then reduce, because you want to make sure that you keep the whole point was to get these 2 denominators to be the same, right? And you might ruin that if you reduce first. Okay, so I would reduce second. All right, let's try it again. This time we're going to look at it with a mixed number. We're going to still do the same steps, right? So here, in this example, I'm going to go back to red to start with my LCD. I'm going to erase this, though. I don't want this in the way. We don't need to see that right now, so I just want it out of the way. Okay. So I have 4 3/5 and minus 1/4. I can't subtract these because they have different denominators, right? So what I should do first is to find the LCD. I find the LCD by listing my 2 numbers and writing down their multiples. So I just have to count by 4s, essentially, and then count by 5s. So 4 times 1 is 4. What's 4 times 2? 8. 4 times 3? 12. Then 16, 20, right? So now let's count by 5s. 5 times 2 is 10. 5 times 3, 15, and 20, all right? So I want to keep going until I see a number that they have in common. In this case, the number that they have in common is 20. That's the first number they have in common. That's how I find my LCD, right? This is what I have to do. I have to list the 2 numbers and then their multiples. So now I have to change both of these fractions into fractions of 20. So I have to do 3 over 5 is equal to some fraction over 20, and 1 over 4 is also equal to some fraction over 20. How do I get from 5 to 20? What do I have to multiply 5 by to get 20?
4.
4, right? And I can always go back to my list. I already made my list, so I can count 1, 2, 3, 4. So I have to do 4. Whatever I do at the bottom, I have to do at the top. So what's 3 times 4?
12.
12. All right. How do I get from 4 to 20? What do I have to multiply 4 by to get 20? Well, obviously it's
5.
5. Whatever I do to the bottom, I have to do to the top. So what's 1 times 5? It is 5. So these are my new fractions, 12 over 20 and 5 over 20. So as you can see, I changed from 4 3/5 to 4 12/20. I changed from 1/4 to 5/20. And now I can subtract. 12 minus 5 gives me 7. So I have 7/20. Remember, I never change my denominator when I add or subtract. The denominator always stays the same. And now I have 4 minus nothing is just 4. So that's how I get my answer, 4 7/20. All right. So to try it the other way that I've already talked to you guys about, I'm going to again just write my fractions Oh, you know what? Actually, let's undo all of that. I'm going to keep it red and then use the blue. So we're going to do 3/5 minus 1/4. Again, I'm going to cross multiply. This cross multiply option may be new to you, but I think it's a good option. 5 times 1 is 5. 4 times 3 is 12. Those are my new numerators. I get my denominator by multiplying them together. 5 times 4 gives me 20. Look at that. Look at how that worked out so easily. It ended up being the exact same thing that we did when we did the LCD, right? So I have 12 over 20 minus 5 over 20. And I think this is shorter than going the LCD route, right? But if you want to go to LCD route, more power to you. But I think cross multiplying works much easier. The only hiccup is that sometimes you do have to reduce, okay? But cross multiplying, I think, saves you guys a couple steps. For me, I have to find the LCD, then I have to multiply it out. After I multiply it out, then I still have to go back and add or subtract. Like, that's a lot. Okay, I think the cross multiplying is easier, but you might have to reduce at the end. So I just want to make sure you guys have both options. Both options are obviously going to work if you do them correctly. Just make sure you're giving yourself the patience to do them correctly. All right, and again, fractions are a super important part of this test. So make sure you guys are really working through these fractions. All right, are we good? Can I move on to the examples? Or are you guys still writing things down? We good?
Yeah, I'm good.
What is the no for? What does the no mean? Can't see it. Sorry, 1 second. Move my mouse. Okay, yeah, we're gonna do more examples. That's what we're doing. Okay, all right, I'm gonna clear this, and then we're gonna move on to the next page. All right. So here's another example that uses mixed numbers, excuse me, right? So these mixed numbers, they have different denominators, right? And so they have to find the LCD, the lowest common denominator. What is the lowest common denominator between 4 and 8? Well, 4 times 2 is 8, so 8 is going to be my lowest common denominator. That means I get to keep this fraction the way it is. I don't have to change anything about it, but I do have to change the 1/4. I have to change the 1/4 into a new fraction of 8. So how do I get from 4 to 8? What do I have to multiply 4 by to get 8? I have to multiply it by 2. Whatever I do to my denominator, I need to do to my numerator, which gives me 2 over 8, which is what I have here. So I changed from 1 1/4. I don't want to use that fraction anymore. It doesn't work for me. So I have to use 1 2/8. Now I can subtract. Now these are good. Now they're good to subtract because you can't subtract until they have the same denominator. But what's the problem here in this example? What's my issue? My issue here is that I now have 1/8 minus 2/8. I can't take 2 from 1. So, as this example is showing me, I have to borrow 1 from the 2. So the 2 now becomes a 1. And I have to add 1 to my fraction. remember that any number over itself as a fraction represents 1. So 8 over 8 is equal to 1, just as a fraction, right? Any number over itself is a fraction of 1. So if I do 100 over 100, that just means 1. 2 over 2 is 1. So I've borrowed 1 from my 2 to make it, so 2 minus 1 is 1. And I'm adding 1 as a fraction to my 1/8. So now I just add 1 plus 8 to give me 1 9/8. And now I can subtract the 1 2/8. 9 minus 2 gives me 7 over 8, because 1 minus 1 gives me nothing. Okay? So that's one way to do that. When we're working with mixed numbers, we have two options. We can do it this way. That means keep the numbers mixed. Or if it's easier, we can convert them to improper fractions before we subtract. And that might be easier for us. When we convert this one, we have to do 8 times 2, which gives me 16, plus 1, which gives me 17. So now I have 17 over 8. And then I have to convert this one. 4 times 1 is 4, plus 1 is 5. So now I have 5 over 4. And again, I have to convert the second one by multiplying by 2 to get 10 over 8. Now I just do 17 minus 10. It gives me 7 over 8. So you have options when you're working with your fractions, when you're working with your mixed numbers. You can leave them as mixed numbers, but then you have to do a little bit more complicated math up here, right? You have to borrow and then add a fraction. Or it might be easier to work with the improper fractions. But if to work with the improper fractions, you have to know how to convert them. That's why it's important to know how to convert your fractions, okay? You have to convert here and then subtract. I, of course, love this way better. I think it's much easier. But if you don't want to convert, you have to do additional steps, all right? So working with your mixed numbers, you have two choices: keep them mixed or convert to improper. I prefer to convert to improper. And that's what I'm going to show you, is the way that I prefer, which is converting to improper. So when we do these examples and this practice, that's what we're going to focus on. All right, here we go. We're going to do the practice now, where we're really going to get into the nitty-gritty so you guys can ask a lot of questions and make sure you guys are doing it correctly. All right. So I need to write 1 1/8 as an improper fraction. So I have to convert it. So how do I convert this? What are my steps?
Y plus 8 plus 1. Y multiplied by 8 plus 1.
Okay, so yeah, 8 times 1 gives me 8. 8 plus 1 is 9, and I keep my original denominator, so this becomes 9 over 8. What's 8 times 1? It's 8. 8 plus 1, 9. So 9 over 8. All right, I'm going to assign a couple of these for you each to do. So I'm just going to assign the numbers now, and then we're going to go over them. So number 2 is going to be for Jules. Jules will do number 2. Number 3 is going to be for Antoinette. And number 4 is for Timothy. All right, so those are your numbers. We're going to start with number 2 with Jules. So what's the answer for this one? 4 1/5 is equal to what?
4 to 1/5 is equal to 21.
Over?
Okay, 21 over 5.
Good. 21 over 5. Good. And he got that by doing 5 times 4, which is 20, and then adding 1 to get 21, and then he kept the denominator. All right, Antoinette, you're up. What's number 3?
I'm here, Mr. G. Okay. 3 times 1 is 3. It's 6 over 3.
3 times 1 is 3 plus 2.
Yeah.
What's 3 plus 2?
4 over 3. Sorry, 4 over 3.
5 over 3.
Huh?
3 times 1 is 3 plus 2. 3 plus 2 is 5.
Oh, okay. I was doing it wrong the whole time. My bad, Mr. G.
No worries. That's why we're doing it. We got to practice. We got to practice. Okay, good.
Yeah, I'm writing them down.
All right.
All right.
Timothy, you're up next.
All right, 16 times 2 is 32 plus 3 is 35
Great.
over 16.
Perfect. Okay. That's all there is to it for these. All right. We just got to make sure you're following those steps. But yep, multiply the denominator to the whole number, add the numerator, and that becomes your new numerator, and keep your old denominator. Perfect. Okay. All right, so now we're going to do the mixed number. The mixed number is division. So it's slightly more work, but not a lot more work, right? And so we're going to divide the numerator by the denominator. So we do 4 into 10. How many times is 4 going to 10? It's going to go in twice because 4 times 2 is 8. I'm going to have 2 left over. So I'm going to have 2 and 2 fourths because the 2 becomes my new numerator. I keep my 4 as my denominator. Okay, so we have 2 and 2 fourths. I need to reduce this 2 fourths, right? Because I can't leave that like that. That can be made smaller. It can both be reduced by 2. 2 divided by 2 gives me 1. 4 divided by 2 gives me 2. So my answer is actually 2 and 1/2. Okay? You do have a choice here because if you notice, even before we do the division, we can see that 10 over 4 can be reduced. So you can reduce it first. If you reduce it by 2 first, you're going to have 5 over 2. And then when you do 2 into 5, you're going to get 2 and 1/2. Okay, you're still going to end up with the same answer. Okay, all right, so let's see who else is in class today. We're going to pick on everybody, all right? All right, so number 2, and you can write it in the chat, Tishelle, when you do it. So number 2 is going to be for Tishelle, number 3 is for Calvin, and number 4 is for Antoinette. All right, so those are your numbers, 2, 3, 4. So whenever you're ready, Tishelle, you can put your answer in for number 2. And yeah, we'll just wait for you to do number 2, and then we can move on. So how many times does 2 go into 19?
9 times.
Mm-hmm.
8.
So for number 2, this is what we're doing, right? We're dividing 2 into 19 to make it a mixed number. We get 9. 9 times 2 is 18. Our remainder is 1. So it's 9 and 1/2 for number 2. It's 9 and 1/2. All right, number 3, Calvin. I'm not sure if Calvin's on. You on here, Calvin? All right. So how many times is 3 going to 25?
8 times.
8 times, right? So 3 is going to go to 25. 8 times, we're going to have 24. 8 times 3 is 24. So we have 1 left over. So it's 8 1/3 for number 3. All right. And the last one, number 4, was for Antoinette. Antoinette, did you get it? Did you do it?
I'm trying to work it out right now, Mr. G.
Okay, all right.
What is it? 9 go into
8 goes into 9.
8 go into 9 one time.
Okay, good. 8 goes into 9 one time. What's 1
And
times
1
8?
times 8 is 8.
Good. So what's 9 minus 8?
That's 1.
Okay, so it's 1 and 1,
over
8.
1 over 8.
Yep, so it's
So
1.
it's an extra 1.
So the extra 1 becomes your numerator.
Oh, okay.
Yeah, so it's 1 and 1/8.
Okay.
Okay, good. All right. So the last thing we're going to be able to do today is go through the reducing. So we're going to do part C. We're going to reduce. That means on Wednesday, we'll do part D. Part D is the part where we're adding and subtracting both our regular fractions and our mixed fractions. So we're going to do part D together on Wednesday, but we'll finish part C right now where we're reducing into the lowest terms. So for part C, I'm just going to figure out what number goes into both 6 and 32 evenly. They're both even numbers, so why not just use 2, right? Let's just reduce it by 2. All right, 2 goes into 6 3 times, and then 2 goes into 32. Half of 32 is 16. So this can't be reduced anymore because the only number that goes into 3 other than 1 is 3, and 3 does not go into 16. So that's my answer. It's just 3 over 16. All right. So let's do some reducing. And so I'm just going to have some people who feel comfortable just reducing for us. So for number 2, any volunteers to reduce number 2? What's the answer here? Or if you know the answer. 21 over 35. What number are we going to do?
3/4.
3/4. Okay. 3/4?
No, 3/5, 3/5, 3 over
3/5.
5.
I mean 3/5. Yeah.
Yeah. We're just reducing by 7, right? 7 goes into both of these. 7 times 3 is 21. 7 times 5 is 35. So we got 3/5. All right. What about 18 over 24?
3/4.
Good. This one is 3/4, right? You might have been jumping ahead. This one is 3/4 because you're just dividing by 6 to give yourself 3 over 4. And the last one, number 4, we're going to divide both of these numbers by 3. 3 goes into 12.
4 times.
4 times, and 3 goes into 15.
5 times.
5 times. So now you have 4/5. All right.
Oh my God, I know how to do something.
Of course you do. All right. So parts A, B, and C that we went over just now correspond to your notes lettered also A, B, and C. So if you need to go back and see those notes, they're there. You also have these examples and this recording, which will be available later. So as long as you guys have done your pre-assessment and the warm-up, you guys are good for the whole day. There's nothing else I need from you for today because your notes aren't done, and that's okay. Your notes will be hopefully be finished on Wednesday. We're gonna upload them on Wednesday. So you guys are done with math for today. Make sure you're back here at 11 on Wednesday to finish up these notes and to make sure we get some time to go over some of those practices that you guys need to turn in for me. All right. Do you guys have any questions for today?
Yeah, please, what's the assessment for today?
You're good. Your assessment is good for today. You've done everything you need to do for today as far as assessments go.
Okay.
Hey, Mr. G, do you want me to send you an email or write in the chat that I need a tutor?
No, you already told me.
Oh, okay.
Yeah, I already requested yours. So as soon as somebody is available for you, I'll let you know.
Okay.
I have a question as well.
Yep.
I want to know if I have to go back to the other weeks that I wasn't here and go over that stuff too, because I got a lot of assessments. I mean, a lot of stuff that's in my
To do.
courses,
Yeah.
like notifications. But I was wondering, do I have to go back because I wasn't here, or?
So I would not go back, especially for me in my class. I'm going to tell you, for me in my class, focus only on this week, on week 3. You do not need to go back right now. But you see the topics there, that all the topics are labeled. If there's something that you think you need to work on and you have time, I would go back. But right now, focus.
Okay.
All right. Your reading teacher might tell you something different when you meet with her tomorrow. But for week 3, for me, focus on week 3. All right.
Okay, this is my only class today, or?
This is your only class today.
Oh, okay.
You got the whole rest of today to do all kinds of math. Do as much math as you want to do. And then tomorrow you have your reading class. All right, y'all. I will see you all on Wednesday. Have a great day.
Bye, Mr. G.
Bye.